Hi, this is Aksa. I'm a PhD student at SameU, and I'm going to present my work on analyzing third-party dependencies in modern web services. This is a collaborative work with my advisors, Vyas Sekar and Yuvraj Agarwal. The study is motivated by the DDoS attack that happened on a third-party DNS provider named Dyn in 2016. During this attack in 2016, a lot of popular websites such as GitHub, Spotify, and Twitter were inaccessible for many hours. In fact, the list of websites that went down goes on. It includes almost all the popular web services we know. So how were the attackers able to take all of these down? This was possible because all these websites, such as Netflix, exclusively relied on Dyn as their authoritative name server. As a result, when Dyn was DDoSed, a lot of websites were inaccessible to millions of users. Attacks like these raise many questions about the resilience of the internet, how easy it is to bring down the internet. Particularly, we need to understand how prevalent these kind of third-party dependencies are. For example, how many other websites are at risk of Dyn-like attacks? Secondly, are there other hidden dependencies that we also need to know about? There might be inter-service dependencies, for instance, a DNS provider being used by a CDN provider. And finally, since Dyn attack had such a huge impact, it is natural to think that websites would adopt as a result. How has the world changed in response to the Dyn attack? For example, did websites stop using Dyn, or did they start using multiple providers? To answer these questions, we analyzed top 100,000 Alexa websites, where Alexa is an external website ranking service which ranks websites based on popularity. To see how the world changed in response to the Dyn attack, we look at the dependencies of top 100,000 websites in 2016 and in 2020. To scope our problem, we only look at three main services. Number one is a domain name system, or DNS. The second one is certificate validation by CA, which is typically done by deploying OCSP servers and CRL distribution points. And the third one is content delivery networks, or CDNs. Given these services, we need to identify what exactly we want to measure. We are interested in third-party dependencies. For instance, here TechRadar uses Let's Encrypt, which is a third-party certificate authority. We are also interested in indirect dependencies. For instance, Let's Encrypt uses Cloudflare as its authoritative DNS provider, and hence TechRadar has an indirect dependency on Cloudflare. Finally, we are also interested in critical dependencies. For instance, here, Let's Encrypt has a critical dependency on Cloudflare because if Cloudflare goes down, Let's Encrypt OCSP servers will not be accessible. So in case of DNS and CDN, we measure critical dependency by looking at if the service provider or website is redundantly provisioned or not. In case of OCSP, we look at if the website supports OCSP stapling or not, which TechRadar doesn't, and hence TechRadar has a critical dependency on Let's Encrypt. To give you a teaser of our main results, in terms of prevalence of third-party dependency, we found that 89% of the top 100,000 websites are critically dependent on either a third-party DNS, CDN, or CA provider. Moreover, we also found that a single provider can take down almost 30% of the websites in the top 100,000. In terms of indirect dependencies that result from inter-service dependencies, we found that indirect dependencies amplify a provider's concentration by as much as 23 times. With respect to how did the world change after the Dyn incident, we found that there is no significant change in website dependency in using DNS, CDN, or CA providers. However, in terms of inter-service dependency, we see a decrease in their critical dependency by as much as 8%, which is an encouraging result. To know more about this work, please have a look at my paper and listen to my full talk. Thank you so much.